Hey, hi all. Good crowd here. I was expecting less actually, given it's Friday morning, but good morning, everyone. Today we are going to talk about how you can operate applications on-prem and especially on edge devices using Systems Manager and the integration with IoT Greengrass. We are going to tell a story here. So I'm going to assume I opened up an automated factory which has industrial equipment, some industrial PCs, you have robots running around, a few trucks, and so on and so forth. What we typically see is when you do such things, you also need some sort of on-prem compute. So customers use either their own on-prem data center or AWS Outpost to make sure that things that require a lot of data or ultra low latency can be processed in-house. And then frequently they aggregate data across many of these factories into the cloud and use EC2 instances to then process it. Now very shortly you realize you very suddenly have 4 different sort of device types. You have in the factory edge devices and industrial equipment. You also have your on-prem data center running with instances. You have AWS Outposts. And then on the cloud, you have EC2 instances. And you need to make sure that all of this is secure. It's compliant to necessary IT standards. And then it's all operational and working fine, right? It's available and it's doing what it's supposed to do. And trust me, that can be challenging. And so what we are here to disambiguate and pull the threads on is how you can do all of this using the offerings of AWS. So very quickly, moving to the agenda, we'll talk about why it's challenging. We'll talk a bit about what we have heard from customers and what are the challenges associated with it. We'll then go a bit into how Systems Manager can help address this, the system software side of the problem. We'll then go into how using Greengrass and Systems Manager together, you can actually do end-to-end full software stack management of edge devices, so both applications and system software using one integrated tool. And then my friend Ravi here, who's a solution architect with AWS, is going to give a short demo. So I opened my factory, and then what I realized was to keep it secure, compliant, and operational, 2 people knocked on my door. One was an IT administrator, and she basically told me 2 things are super important. One, you need to ensure that all these devices have the right desired state configuration, right? They're configured properly and securely. And we also needed to ensure that there are no drifts, so this configuration is maintained. That's one. 2, she mentioned there needs to be OS updates on them to keep them secure and make sure there are no critical vulnerabilities or security patches that have not been installed. Super important. So those 2 were the ones that my IT administrator told me it's very important. Those are the system software side of it. And then edge developers knocked on the door and said, we need to manage our edge device applications. So we need support for things like deploying the application code on the devices. We need support to broker data between your edge devices and the cloud. We need support for running ML models on these devices and make sure everything remains operational at the same time. It's very rare, but in some cases, these 2 personas also meet together and say both of them need troubleshooting, something very important. So typically what I get requests for is we either need to execute remote commands to troubleshoot issues or get SSH access into the instances, and all of this has to be done securely. So I said, okay, that's fair. We have 5 set of use cases here. That makes sense. But what are the challenges with it? That should be fine, right? So we went back. We asked customers, what are the challenges with it? And we got 3 high-level challenges that most customers faced. One, because you are managing 4 device types, so EC2 instances on the cloud, edge devices, AWS Outposts, and on-prem instances. And you need to keep these IT operational policies consistent across all of these devices. It becomes tough. What we've seen customers do is they kind of use different tools for managing all of these different devices and then build homegrown scripts to integrate them into all to make sure that policies remain consistent, everything remains compliant, and so on and so forth. That's hard. That's because you need to use multiple tools and maintain this homegrown script. So that's one. Two, the other thing we realized was customers use different software to manage system software and something else to manage applications, which means you're using multiple toolkits. So you have to switch between consoles. You need to learn 2 different tool sets, which is tough and which can cause inefficiencies. And lastly, troubleshooting is pretty complex. So what we have seen a lot of customers do is send out technicians to the field to access the device, troubleshoot it, and get back. I know of a major medical equipment manufacturer who sends technicians all around the country to more than 1,000 hospitals in order to debug and troubleshoot some of the medical equipment installed in the hospitals. That very quickly becomes expensive. Other options that we have seen other customers use is either some sort of reverse SSH, opening inbound ports from your firewall, or setting up Bastion hosts. Now, these solutions, while they work and they are remote, they require significant amount of technical expertise to implement as well as maintain. So effectively, the problem is that these solutions are inefficient. You need certain level of technical expertise to deploy them, and they are pretty expensive, especially the truck rolls where you have to send people out become very expensive very quickly. And so we said, how do we solve it? And we realized that this problem was not unique to edge devices. These were problems that we were solving for our EC2 customers for long with Systems Manager. And we heard very good reviews about Systems Manager, especially the scale and the simplicity of it. And so what we are now supporting is, with Systems Manager, we are now extending support to these edge devices. So you can use it to manage these kinds of edge devices, make sure they are patched, make sure they are configured, and so on and so forth. And so all the good things about using Systems Manager to manage on-prem and EC2 instances is now extended out to the cloud. So going ahead a bit, right? So what advantages does this create? So the first advantage basically is that you can have an integrated management tool to manage all 4 device types. So you can manage EC2 instances, on-prem instances, AWS outposts, as well as edge devices, all through one single interface in Systems Manager. And now you don't need to maintain homegrown scripts to keep the policies consistent, because all of them stay within Systems Manager. So now using one tool, you can manage it end-to-end and across device types. So that we heard is a great mechanism. So for example, we know that in one major metropolitan city, a company operating a fleet of vehicles is using Systems Manager to manage more than 1,000 such routers that are installed in their vehicle fleet. And then they do patching and configuration management. So basically, they provision and maintain desired state of their devices using Systems Manager, which is pretty powerful, and they love the solution. So that's one. 2, until now, you needed some level of setup to actually set things up like patching or configuration management, provision your devices, and so on and so forth. But now, using more than 100 pre-built operational runbooks of Systems Manager for common use cases, such as patching, you can use these out of the box, and they're available to everyone to use, and use these to run these operational use cases. So this helps you really automate repetitive tasks using Systems Manager. And lastly, Systems Manager has a feature called Session Manager that enables you one-click CLI access, and you don't need to send technicians out. You don't need inbound firewall ports, and you don't need to set up Bastion hosts or set up reverse SSH. It just works out of blue, and I think we'll see it in the demo, which is pretty amazing. And we do this all with safety and security, which is provenly works for EC2 and on-prem instances, and now we are extending to edge. So all this worked perfectly for EC2 and on-prem, and now it also works for edge devices, which is pretty amazing. going to move on a bit. Let's go into a few details, right? So how does this work? I frequently get this question. I'm going to show how we can make this work for 3 use cases, which are pretty common from what we have heard from customers. So kind of the first use case that we'll go into is patching. The second use case we'll go into is provisioning and configuration management. And third, we'll see how session manager or one-click CLI access works. We'll also talk about how this works with other systems manager features as well as AWS services to give a very integrated experience. So it all starts with a systems manager agent on the device, which is an open source component. Its code is available in GitHub that runs on the device itself. Now, once you have the agent running on the device, it frequently pings back to the cloud to talk to the systems manager backend service to get commands and so on and so forth. Now, once your agent is pinging back, let's talk about the patch use case. Now, in order to automate patching, and we have frequently heard customers patch every week, every 2 weeks, every month, based on what the company policies are and IT policies are. And typically, customers today use maintenance windows along with Patch Manager to automate that process of patching. So every week, a maintenance window runs for 3 hours and ensures that all your devices that need to be patched get patched, and you can automate it. We have pre-built runbooks for supporting these use cases, so you don't actually have to write how to patch it. We already have that support, which allows you to also define multiple levels of rules on what gets patched. So that's one use case. The second one is provisioning and provisioning use case, right? So making sure required softwares are on the device and stay on the device. For that use case, we have something called Systems Manager State Manager. And with this feature, you can write a desired state, and the system ensures it's maintained. Now, you can also use other popular configuration management tools out of the box, such as Chef, Puppet, or Ansible, to make sure your fleets are provisioned. That's a very strong use case that we have seen customers adopt broadly, and that, again, uses pre-built Systems Manager runbooks to make it work end-to-end. So you don't need to have too much technical expertise. This just works out of the box. Lastly, we have something called Session Manager, as I previously mentioned, to directly give you CLI access, which is pretty amazing. Now, all of this is very natively integrated into other AWS offerings. So for example, with Fleet Manager, you will be able to see what processes are running on your device. You can directly, remotely on your browser, see the file system, and you can see how much CPU and other performance counters right on the browser. So that's pretty good. It's also integrated with automation that allows you to build and run more complex workflows for some of these use cases, which is pretty heavily used. And then it fits very natively into other systems manager features for operations management and change management. So if you have some incident that's going on, you can automatically create an incident out of it and run a runbook to make sure that appropriate steps and an incident response plan is created and the incident is responded to appropriately. What it also natively integrates it with is CloudTrail as well as config to make sure that all of these devices remain compliant to standards. So something that I've heard used a lot is customers need to make sure there are no blocked software on these devices, which config can help with, as well as CloudTrail to make sure you're auditing everything and everything remains compliant and auditable. So that's the beauty of it, because everything comes together inside AWS and allows you to drive end-to-end use cases. So let's go into a bit more detail on what we talk about integrated management in this context. So here we have a screenshot of Fleet Manager, which lists all your edge devices along with EC2 instances and AWS Outposts, as well as your on-premises devices, all in one screen. So that you, as an IT admin, you now automatically get holistic view of your entire infrastructure. You don't need to go to 5 different tools or build your homegrown scripts to merge this data. All of this is aggregated into one single console. As I mentioned before, um, the tool also enables you to view the file system, view performance counters such as CPU, as well as view running processes, and so on and so forth. So that makes it a powerful and compelling story. Next, let's talk about how these pre-built runbooks help. So as I mentioned, we have more than 100 automated pre-built runbooks, which enable you to automate repetitive tasks so that you instead focus on things that are specific to your use case and differentiated. Now, these tasks, we have seen customers use it a lot for provisioning software as well as keeping their devices patched. And the beauty of it is that we have built-in safety controls that make sure that your environment remains available during this time. And if errors occur during patching, they automatically get halted based on a certain error threshold. Customers have used this at scale for managing EC2 and on-prem instances. And then we are extending this to the edge. So that gives a good amount of assurances that it'll work on the edge. And we have seen customers use it on the edge at scale as well. And they're pretty happy. Lastly, as I mentioned, you can securely troubleshoot. So you can open up a remote SSH session on a browser console directly using Session Manager. The beauty of it is this does not require you to have Bastion hosts. This does not require you to open inbound firewall exceptions because it's the agent who talks to the backend. And this does not require you to manage any SSH keys. So it's kind of SSH, but it's CLI access for your instances. It's integrated very natively with IAM to make sure that only required people and required roles and users get access to the device. And this saves a lot of time and money. We have had a company who, again, it's a medical industry-based company who used to earlier send technicians to kind of debug a different kind of device in hospitals. And they deployed it to more than 2,000 of their hospitals, with each having around 500 to 1,000 devices, and then they're using Session Manager to remotely access it. They have saved, from what I gather, thousands of technician visits every month, which are generally required because these devices generally require some sort of troubleshooting, which is a large cost saving. So now this kind of helped the IT admin persona a lot, right? You got a thing, a tool that enables you to keep policies consistent, integrated tool to manage all 4 kind of devices we talked about. We got great troubleshooting access, and the need for technical expertise reduced because you had hundreds of pre-built runbooks. But let's talk about a bit more about the developer persona, right? Developer persona here also had a few things that they asked for. Common things were deploying ML models, brokering data from the edge to the cloud, making sure that their application was managed as well as their device fleets were monitored. And so we have seen a lot of customers use Greengrass for that purpose. So AWS IoT Greengrass supports these use cases. And now we natively integrated Systems Manager with AWS IoT Greengrass. So from one stack within AWS IoT Greengrass, you can manage both applications that customers already use for managing applications, and then extended that to support system software as well. So from IoT, so this is kind of what we've seen customers love IoT Greengrass for, right? You can manage device software, you can control your fleets, you can broker data, and then you can run ML. And it basically makes sure that it's secure, the data is secure both at rest as well as in transit, especially when you send it from the cloud back to the edge and vice versa, or let it be commands. So you were able to do this securely and at scale. And with this integration of IoT Greengrass with Systems Manager, you can manage both system software and applications at scale, all from the IoT Greengrass console. So on the left, you see a screenshot of the Greengrass console that enables you to do 3 things, right? So you can patch your devices on demand. You can start a session, which just basically opens up a browser-based shell with a click, or you can run remote commands at scale on these devices. Because it's natively integrated with a simple wizard-based experience, you can install the SSM agent on the Greengrass device and make sure it works end to end. So that's pretty much what I had. And presentations are always great, but we love to, as AWS, get to the demo side of it and see it actually work. Let's go through a quick demo. I have one slide on how it's priced, but I would love to show that after I hand it over to Ravi for his demo.
Thank you, Abhishek. Hello, everyone. My name is Ravi Taluri. I'm a principal solutions architect within the transportation vertical for small and local governments. Prior to this role, I was a solution architect within the automotive vertical. And one of the challenges that we consistently talk about is firmware over the air updates for the vehicles that are out on the road. And the challenges that the automakers were looking at was, how do we have a turnkey solution that can run these firmware over the air updates across millions of vehicles? And if there is an issue where you don't need this vehicle to be brought into a dealership, because that entails cost, that entails there's security involved, there's privacy involved. So we started having discussions with the systems manager team, and an offshoot of this is this particular new service. And from a demo perspective, what we have done is created a EC2 instance running Amazon Linux. This release supports Amazon Linux, Ubuntu, Mac OS, as well as SUSE Linux. Eventually, this will start getting ported out to different flavors of Unix that would be relevant for the edge devices. So as Abhishek was going through his presentation, what I did was created a EC2 instance, Unix EC2 instance running Amazon Linux. And what I have is this has Greengrass running on it. And I'm going to deploy the systems manager agent.
So systems manager agent is a public component within Greengrass. So on this wizard, you can just select that public component and configure it.
And then configure that component with IAM privileges to communicate back to the SSM service.
So what we are doing here is SSM service, or the SSM agent requires IAM credentials to talk back to the cloud. And so we created a role beforehand that enables that policy and gives it access to talkbacks. And so the way it works is when you're configuring that component, you need to tell Greengrass about that role, because when it installs the SSM agent, it ensures that those privileges are passed on.
So Now, once the agent is installed, you'll show that device, IoT device, pop up under Fleet Manager as an IoT device that's being managed by Systems Manager.
Yeah, so you see a new device coming up.
This is the new device. And then going back to Habib's presentation, what you have is the ability to run, patch the node, as well as start a terminal session. This is for debugging purposes or any other troubleshooting that would be required. If you look at the patch details at this point, there isn't an inventory of the patches that have been installed on the system. So I'll take you the process of installing the patches as well, and then you'll see the section being updated. And then you also have an overview of the file system. It gives you a listing, performance counters, so memory and CPU utilization, processes. And then just for purposes of this demo, what I'm going to do is run an Ansible playbook for installing an Nginx web server. This points to S3.
You need to change the source.
Yep.
Ravi, you need to change the source. Yeah.
Okay. Thanks. And then you could have different sets of criteria in terms of where you want this particular software to be installed. You could specify instance tags. You could choose instances manually or choose a resource group. For purposes of this demo, I'm choosing the instances manually.
We have seen a lot of customers use tags. So typical tags are based on the region or the business use case or the environment. They set up different tags for their devices, and then rather than installing, or configuring them all together, that gives you a very good way of setting up logical differentiations on how you want to make your deployments. That we have seen is a very common way to do it. The other way we see it a lot is build resource groups, and then which enables you to kind of manage these devices as a single application, and then create a deployment against resource groups.
So within the automotive space, this would be where an OEM might want to run a campaign that would say, hey, run against all these model variants for this particular model year in a particular region. It depends on how the customer wants to categorize these devices. It takes a while to go ahead and install. So what you see is a success.
Right. I think you can use Session Manager to show it. So this device originally didn't have Nginx installed. For the purpose of this demo, we had uninstalled it. And then we just installed it through the runbook.
So now you have Ansible and Nginx running on that particular system.
You can patch them also.
Yeah. I'm going to run patching on this particular node.
So in the purpose of this demo, we ran a scan, but you can also install patches using the same flow. Third one.
So if you see this section has been updated with all the patches that have been installed on that particular device. This concludes the
Yeah, I
demo?
think so. This demo kind of showed you the 3 use cases I was talking about. We first went through Session Manager to see how you could troubleshoot issues which give one-click CLI access. Secondly, we had a typical provisioning use case running where we installed Nginx. We have seen customers use Ansible playbooks, chef recipes, and Puppet runbooks to install other softwares, agents, or simple configuration management as well. And all of this is provided using pre-built runbooks that are offered by AWS. And lastly, we saw how you could patch your devices on demand. So you could both scan for patches, as we did in the demo, or install patches, all using one single tool in Systems Manager. If we can just switch back to the linking. Yep, great. So let's talk a bit about how this is priced. So we have 2 tiers of pricing, right? We have a basic tier, which enables integrated fleet management. You can install patches and firmware upgrades, and you can do provisioning and configuration management using more than 100 runbooks. And you can manage up to 1,000 devices every month. And that's offered at no additional charge over on top. Now, if you move to the advanced tier, which allows all this with Session Manager, which provides one-click CLI access, and if you need to manage more than 1,000 devices, it's charged at $5 per month. It's prorated by the hour. So if you, for example, have the device on for 15 days of the month, you would be charged $2.50 for that device. It's prorated by the hour. And yeah, that kind of concludes what we had. We would love to open up to any questions that you guys might have for us, or any questions on the demo. We are pretty much open to anything. Yep. Yeah, so I'll just repeat the question because we are recording audio. I think the question basically was that does the remote session run on regular SSH, or does it use some other mechanism? So it doesn't work on regular SSH. What it does is, because the agent pings back to the main backend cloud service, it uses that open channel to kind of open a session for you. So because it's not regular SSH, you don't need to manage SSH keys, and you don't need to open inbound firewall ports to kind of allow for SSH access. So it's better security posture as well as it's convenient to use.
And all of the traffic back and forth between the device and the SSM service is encrypted using KMS keys, which
Yeah.
$5 a month charge, is that only for devices that are maintained with Greengrass?
No, so the $5 a month charge is the systems manager charge. There's a separate Greengrass charge which is on top. Both are independent charges that you'll see on your AWS bill at the end of the day. I think Greengrass charge is also based on various different factors. Yeah. So I'll just repeat the question. So you asked what operating systems are supported by the agent. So today we support, so just outside of Edge, and I'll talk about EC2, on-prem, and all these devices. So we support Windows servers. We support various flavors of Linux, so Ubuntu, Amazon Linux 1 and 2. We support
SUSE Linux.
We support SUSE. We support CentOS, and there are one or two more, and we can obviously share details. But yeah, effectively, we support our Oracle Linux, for example. So there are a wide variety of operating systems, and we keep adding on to them based on customer requests. So if we have certain operating systems that are required, please feel free to reach out, and we prioritize it based on customer demand. So the agent per se is open sourced. It's available in GitHub. So we have seen some customers just build out their own binaries and deploy it to the instances themselves. So it's an open source agent. It's on GitHub, so there's nothing stopping customers from changing it. We have seen, especially with Session Manager, and that SDK is also open source. So we have seen customers take that and build their own customization on top and then expose it to their internal customers. That's a very common use case that we see.
So going back to the demo, we had used a public SSM agent component. In case you customize your SSM agent, that would be a private component.
Yeah, we have seen a lot of customers customize it to their own needs, so I think that should be fine.
And I think we should have a discussion about what some of those non-supported Linux variants might be, because eventually we would like to have some of those on our product roadmap as well.
Yeah. Any other questions? Okay, I think we are good. Thank you guys for giving us an opportunity to present this. Hopefully it's useful for you. I'm Abhishek Pandey. He's Ravi. We'll be outside for a bit. If you have any questions, any feature requests, or want to have some discussions, we are open to that. We'll just be outside the hall. Thank you. Thank you.